Good morning students. Welcome again into the 12th science chemistry class. From last two lecture we are learning the chapter number 3, that is the equilibrium, that is ionic equilibrium. Now we already learned about the ionic equilibrium, strong and weak electrolytes as well as strong and weak acids and bases, how they ionize, and what is the dissociation constant of weak acid and weak base, and how the Oswald dilution law we prove that is the degree of dissociation of the weak electrolyte, it may be weak acid or weak base, is inversely proportional to the square root of concentration and directly proportional to the volume of the solution. Now in last lecture we solve some problems such as 3.1, 3.2, 3.3. Now this is the problem number 3.4. What is given then in this problem and what they ask us to calculate? Now calculate the H3O plus ion concentration. This square bracket means concentration. So we have to calculate the concentration of H3O plus ion, that is the hydronium ion, in 0.1 mole per decimeter cube solution of acetic acid. Now acetic acid is the weak acid and it ionizes in a very small amount. So the K, that is the dissociation constant of this weak acid, acetic acid, is given. It is equal to 1.8 into 10 raised to minus 5. And they ask us to calculate the H3O plus ion concentration. So student, we know that in the aqueous solution the H plus ion, that is the bare H plus ion, is not present. The proton, that is the H plus ion, is always present in the aqueous solution in the form of hydronium ion, and the enthalpy of formation of hydronium ion is also calculated. That is the proof that H plus ions are always present in the form of hydronium ion. But for convenience, we take in the reaction as H plus ion for our writing convenience. Now, if we want to calculate the concentration of this hydronium ion, we must require the alpha, that is the degree of dissociation, because we know that in case of weak electrolyte, the concentration of ions is calculated by the formula alpha into C, that is degree of dissociation multiplied by concentration. Now here concentration is already given 0.1 moles per decimeter cube, but alpha is not given, but they give us the value of K, that is the dissociation constant of the weak acid, and from the value of K we can calculate the alpha, because we know the formula alpha is equal to under root of K divided by C. We learned in the Oswald dilution law. So let us first calculate the alpha. Let alpha is the degree of dissociation. Concentrations of various species in water at equilibrium are as follows. Now after ionization into the aqueous solution, this acetic acid gives acetate ion and hydronium ion. Now this H, that is the hydrogen H plus proton of the acetic acid accepted by this water molecule, and there is formation of this H3O plus, that is the hydronium ion. Now we know that acetic acid is the weak acid, so it dissociates very that is in a small proportion. Suppose only alpha get dissociated. So what is remaining at equilibrium, that is of the this unionized molecule remaining at equilibrium of this acetic acid is 1 minus alpha. And what will be its concentration? Now 1 minus alpha into C. This is the concentration of these unionized acetic acid molecules. Now the ions, as only alpha get dissociated, so the concentration of these two ions, both ion is alpha into C, alpha into C. So if we calculate this value alpha into C, then we have there the concentration of this hydronium ion. So let us first calculate this alpha by using the formula of Oswald dilution law, that is alpha is equal to under root of K divided by C. Now the value of Ka is equal to 1.8 into 10 raised to minus 5 is given. Concentration is 0.1 mole per decimeter cube is given. Now this 0.1 mole per decimeter cube means 1 into 10 raised to minus 1 or 10 raised to minus 1 mole per decimeter cube. So just on substituting the value of this Ka, that is the dissociation constant, and the concentration C, we obtain alpha is equal to 1.8 into 10 raised to minus 5 divided by 0.1 means 1 into 10 raised to minus 1. Now this minus 1 goes to the upper side, it becomes plus 1. So only 10 raised to minus 4 is remaining. Now see on the blackboard again. Now what is there? Alpha is equal to now 1.8 into 10 raised to minus 4. Now if we want to this 10 raised to minus 4 to the outer side of the square bracket, then it becomes 10 raised to minus 2. Remember that. Sorry, square root. The square root of this 10 raised to minus 4 is 10 raised to minus 2. And the square root of this 1.8 you can directly see into the log table, or just a student see the log of 1.8 divided by the 2 and see the antilog. You will got this value 1.34, and this 10 raised to minus 2 is as it is. On taking the log of 1.8 divided by 2 and then see the antilog, then you got this value. You will got this value 1.34 into 10 raised to minus 2. Now this is the alpha. Now calculate the concentration of this H3O plus ion. Now concentration of H3O plus ion is equal to alpha into C. Now the value of alpha is 1.34 into 10 raised to minus 2, and this is the concentration 1 into 10 raised to minus 1, that is the 0.1 mole per decimeter cube, and it becomes 1.34 into 10 raised to minus 3 mole per decimeter cube. Per decimeter cube means per liter, so it is equal to 1.34 into 10 raised to minus 3 moles per liter. Now let us learn, student, some special property of the water. Now autoionization of water. Water molecules get auto-ionized. So pure water ionizes to a very small extent. Very small extent. Up to 1 into 10 raised to minus 7 moles only get ionized from the 1 moles. Remember that. So pure water ionizes to a very small extent. And the ionization of water at equilibrium is represented as follows. Now how the ionization of water? Take the 2 molecules of water and they get ionized as follows. Now let us learn the ionization of water. Again watch on the blackboard, students. Now we know that there is the autoionization of the water molecules, and at equilibrium the water molecules ionizes as, now this H2O, first molecule of the water, plus H2O liquid, second molecule, and it at equilibrium gives H3O plus aqueous and OH minus aqueous, that is hydronium ion and hydroxyl ions. Now we know that water is very in small extent it ionizes, or in less proportion it ionizes. So it is ionizes very that is in a small extent. So there is the double here arrow between the reactants and products. Now if we apply the law of mass action to this equilibrium, then the equilibrium constant K for the ionization of water is given as, now this K is equal to, we know the law of mass action, that is the multiplication or product of the products, concentrations of the product divided by product or multiplication of the concentrations of the reactant. So K is equal to concentration of this H3O plus aqueous into concentration of this OH minus aqueous divided by concentration of H2O bracket square, because there are the 2 molecules of water. So we take here as the square bracket of the concentration. Now if we take this H2O bracket square to this side, then K multiplied by H2O bracket square, it it becomes. And this is equal to H3O plus concentration into OH minus ion concentration. Suppose this is the X equation. What is that? K, that is the equilibrium constant of water, into concentration of water bracket square is equal to H3O plus concentration into OH minus ion concentration. This is the equation X. But a majority of water molecules are undissociated, because we know that water is dissociated very less. So majority of the water molecule remains as it is, that is undissociated. Very small amount of water get dissociated, that is out of 1 mole of water only 1 into 10 raised to minus 7 moles get dissociated. It is very less value, and therefore a majority of water molecules are undissociated. So consequently, or so, concentration of water, that is concentration of this water molecule, can be treated as constant, that is the K dash, or it can be taken as the constant, that is the K dash. So if we take the concentration of undissociated water molecules as K dash, then how the equation X becomes? Let us see there on the blackboard. Now take the concentration of water as K dash. Substituting this value in equation X, this H2O bracket square as K dash. You can write here also H2O bracket square, but that is also the constant. So take the concentration of this water molecule as constant, because water is very less amount get dissociated. Suppose the concentration is K dash, any constant suppose. Now substitute this value in equation X in this equation. What we got? Now this concentration K into concentration of water bracket square is equal to H3O plus concentration into OH minus concentration. But substitute the value of H2O concentration square as K dash. Then what there becomes? K into K dash is equal to H3O plus concentration into OH minus ion. Now these both are the constant, K and K dash. Suppose that constant after this multiplication of K and K dash is Kw. Now this Kw is the ionic product of water. Why it is called as the ionic product of water? Because what is Kw? Kw is equal to concentration of H3O plus into concentration of OH minus, and these are the ions of water. And so this Kw is called as the ionic product of water, and this Kw is nothing but K into K dash, and it is called as the ionic product of water. And how it is defined? It defined as the product, that is the multiplication, this product, that is multiplication product. So the ionic product of water is defined as the product multiplication of molar concentrations. This square bracket denotes the molar concentration. So it is the product or multiplication of molar concentrations of hydronium ion. This H3O plus is the hydronium ion, or we can also write it as the hydrogen ion, because the behavior of both the ions are same, but this hydronium ion is present into the aqueous solution and not as a bare H plus ion. So the product of multiplication of molar concentrations of hydronium ion or hydrogen ion and hydroxyl ions. The product or multiplication of the hydronium ions and the hydroxyl ions at equilibrium is in the pure water is given at the given temperature is called as the ionic product of water, Kw. So what is Kw? Kw is ionic product of water, and it is defined as the product or multiplication of the molar concentrations of hydronium ions and hydroxyl ions at the given temperature at the given equilibrium state is called as the ionic product of water. Now this pure water, in the pure water H2O plus ion concentrations and hydroxyl ion concentrations are always constant. Remember that. In the pure water H2O plus ion concentration is always equal to the concentration of the OH minus ions. Because both the ions are equal in the pure water, that is the hydronium ion and the hydroxyl ions. So if we take it as equal, that is the high concentration of hydronium ion and concentration of hydroxyl ions, if we take it as equal, then what will happen? Now let us learn. Now pay attention students on the blackboard. Thus at equilibrium and at 298 Kelvin, that is at room temperature, that is 25 degrees centigrade. 298 Kelvin means only just subtract from this 273, you obtain 25 degrees centigrade. So at 25 degrees centigrade or 298 Kelvin, the concentration of both these ions, that is the H3O plus ion and OH minus ion, that is the ions of water, is found to be, both have the concentration found to be 1.0 into 10 raised to minus 7 moles per liter. Now if we substitute this value of this concentration of these both ions in the equation of the ionic product of water, then what will we obtain? Kw is equal to concentration of H3O plus into concentration of OH minus. We know that it is the ionic product of water. Now substitute the values of both these ions concentration here. So Kw is equal to 1.0 into 10 raised to minus 7 into 1.0 into 10 raised to minus 7, and it is equal to Kw is equal to 1.0 into 10 raised to minus 14. Now this is the value of ionic product of water Kw, that is 1.0 into 10 raised to minus 14. Remember students. Now let us learn the pH scale or Sorensen scale. Now Sorensen is the name of the scientist. He found out these pH scales. Now what is this pH scale? Sometimes the concentration of this ion, that is the hydronium ion or H plus ion concentration, is given in the pH scale, which is convenient than in moles per decimeter cube. So the pH scale is developed by Sorensen. And what is this pH? pH is nothing but the power, potential of hydronium ion or hydrogen ion. Potential is the Greek word for the power. So pH scale or Sorensen scale, in this what is there? Instead of writing the concentration of these H3O plus ions in moles per decimeter cube, sometimes it is convenient to express it in on the logarithmic scale. And this logarithmic scale of the found out the concentration of this H plus ion is called as the pH scale, and this is known as pH scale. Sorensen, which is the name of the scientist who developed this pH scale. Now how he defined the pH? Now Sorensen in 1909 defined the pH scale of the solution as it is the negative logarithm of hydronium ion concentration to the base 10. Hydronium ion, for convenience we write it as the H plus ion. So Sorensen defined pH scale of the solution as negative logarithm to the base 10 of concentration of H plus ions in the solution in moles per decimeter. And mathematically how it is expressed? How the pH is expressed mathematically? pH is equal to negative logarithm to the base 10 of H plus ion concentration. In this way we mathematically express the pH as pH is equal to minus log to the base 10 of H plus ion concentration. As there is this scale, pH scale, to find out the concentration of H plus ion, there is again POH is there. That is power of hydroxyl ion concentration, and that is known as the POH. It can be also defined as, similarly, POH of the solution can be also defined as the for the pH is equal to minus log to the base 8 of H plus ion concentration. And what is pOH? pOH is equal to minus log to the base 10 of OH minus ion concentration. Now this is about the pH scale. In the next lecture, students, we learn about the relationship between the pH and pOH. How pH plus pOH is equal to 14. We have to prove that expression. And again we will learn more about that of the pH scale, how it can be drawn. Now if student, you understand this video, this lecture very clearly, and if your doubts becomes clear, then you like, subscribe and share this video so that the other students also get advantage of this video. By watching this video, they also get the advantage in writing their answers in the examinations. It may be entrance examination such as the JEE for engineering, NEET, NEET for medical science, or that is the MSCET for the Maharashtra, which may be useful for our career into the engineering, medical or pharmaceutical, that is field, or any field you must give that MSCET. So this is very useful knowledge. So share that, like that, and you can subscribe this video. Thank you for watching this video. All the best. You can take screenshot of this blackboard writing and write down the notes, students, because this is very important. Thank you.